Appreciate y'all coming out. So, name's Matthew Dowst. Talking about building some resilient automations today. So, what is resilient automation? Right, it's something that is reusable, that you can pass on to your team, that you can do other things. You know, I've worked in consulting for 14 years now, so I have tons of horror stories. Telling these guys about a company I was at where you couldn't turn off a certain laptop or else it would break the Exchange server. Right? I've been to other companies where you had to create every user had to be created in this one OU, stay there for 30 minutes, and then go somewhere else because somebody made an automation that nobody knew how to manage, right? So my goal is to help you not only create great automations, but maintain them and build them in a way that you can easily add to them, keep them up and everything, and then pass them on. So, principal consultant at Quisitive. I run our managed automation team. Also the author of Practical Automation with PowerShell. A lot of the same type of things that we do here. And then also have the PowerShell Weekly newsletter that goes out. And that's just basically things that I found from the community from that week, just to kind of keep everything up to date. Always open for hearing new things too to add to it as well. So all those links and everything are there on that QR code. And then most importantly as well, you guys should feel very special because I'm also the head coach of the Grass Ballerinas, who they are playing tonight, and this is the first game I've ever missed. So we've had a lot of rain in Texas, and it was a random reschedule. So the agenda. Everyone's heard the term, no battle plan survives contact with the enemy. Right? There's always different things that you need to kind of consider when you're building automations. And that's kind of what we want to talk to. And the big part of it is, what if, right? What if this happens? What if that happens? That's the kind of mindset that I want you to think about when you're building automations. Right? So if we take a look at very, very common one, new users, right? What's the new user what ifs, right? User with the same name already exists. It's pretty common. Someone passes an invalid value. Another very common one, we're out of licenses, especially with Office 365 and all those fun things. Or what if a solar flare comes and causes a bit flip and all of a sudden my script stops, right? Probably don't need to worry about that one too much, right? But that's kind of an example of get your mindset going. You don't need to think of every single what if, right? We don't need to code for every single what if scenario, but what you want to do is code for the common things that you can think of, and then build your code in a way that you can then account for those things later on, right? And the big part of that, right, is making things idempotent, right? That's being able to restart a script from the same spot every single time it runs, being able to design things along those lines. So if we hop in, it said pretty much, the universal one is creating a new user. All right, so we'll go ahead and we'll create John Smith, set his department, he works in IT, get his office location, his employee ID, and then his job title, which I'm sure this is what all you guys have, the supreme overlord of all things beeping, blinking, blue screening, master of forgotten passwords, and rebooter of the unrebootable devices, right? And then we'll just go ahead and, simple graph call out to go and set all of those values, right? So we just, some basic string parsing to get the UPN and all of those type of things. And if I run this though, we're gonna come back and we're gonna get an error, right? Invalid value specified for a job title. There is a length limit on job title in graph, unfortunately. So since we failed right there, the entire automation's failed just because I got one bad value. All right, so another way to be able to do that is just take anything out that you don't need, right? So we'll go ahead and we'll create a new user, and we run that again. Uh-oh, we failed again because that UPN already exists. Go figure. We have, there is another John Smith in the world. So we can actually, account for this as well, right? Do a simple lookup. Hey, does a user with this username already exist? I'm sure you've all seen this, a variation of this a million times, right? If it does, add a number to the end, check it again, do a nice little while loop until you get that unique user principal name, right? And then we'll go ahead and create our user again. Right, so now when I run this, it locks up on me because it's, it's a demo. There we go. So now we created John Smith 10. You guys can tell I tested this a couple times before today. But now we have our user, but we still need to set those attributes, right? So we can simply use the update MG user, right? Go ahead and we'll pass all of our attributes into a nice little splatting. Is anyone here familiar with splatting?
It's my favorite.
Yes, yes. So if y'all aren't aware, I do have a commandlet out there called PS modules. And in there is a get command splatting, and it will give you the nice splat for it. But anyway, enough self-promotion, right? So now we can go through and we can set all the attributes. Right, but again, we failed because of our job title again, because our job title is still too long. Again, when you're thinking of automation, do I want to fail for this, right? So further down this script, I could have setting licenses, setting groups, setting permissions, those type of things. Do I need to fail if a job title is wrong? Probably not. That's something that we can go when we can fix later on. Right, so what we can do is we come in and we create our script, get our attribute parameter file. So same exact hash table we were just using for splatting, but this time we're just going to pass each attribute individually, right? So that we can go through, wrap it in a nice little try-catch, and we can then come back and say, okay, hey, how did we go here? So we'll run this through, right? So we saw that we got everything updated with the exception of our job title, right? Does anybody notice what I did do wrong though?
We ran the entire thing again, recreating the user.
Yep, so now we have John Smith 11. All right, so another thing that you would want to take into consideration, right, build for, right? So we need to have a unique identifier for that person, right? So we can take our same exact functionality to get a user, but this time we'll check it against the employee ID, right? So we say this employee ID is what defines this user, right? So if this user has an employee ID that already exists, right? Or if this name already exists, let's check that employee ID to ensure that we're not overriding something. All right, so when we put that all together, it'll come back out. We'll have this, it'll check the employee ID, just real simple. And then obviously we need to include that employee ID in there on the create. But if I run this, now with a valid job title, IT admin, I can run this over and over and over again, and I'm still gonna get John Smith 1, still gonna set those values. And then of course, VS Code does that to me, but we keep those things. So like I said, the idempotent, the being able to restart it from wherever you left off, right? Not having to go, oh, where did this fail? And then getting someone to come dig down in here, and you don't want to do that with your scripts, especially when you're sharing those scripts with other people, right? If you're going to build this into some Azure Automation runbooks or some functions or other things like that, they're going to run on a schedule, right? You want to be able to maintain that and kind of keep those repeating. So another very common example is API calls, right? What if there's paging, right? So I need to make that call over and over and over again. A lot of these things will depend on the API you're working with, but the fundamentals, will remain the same. What if I get throttled? What if my access token expires? So everybody who's worked with Graph knows all three of these really well. What if I'm a little teapot? That's probably the one I don't need to worry about too much, right? But we can still account for it. So, who can tell me what's wrong with that function? Now, let me scroll down a little bit so you can actually see what's wrong with it. It's calling itself over and over and over again, right? Which, if you have paging, that's what you want. You want it to keep running, right? But what if something goes wrong? What if you get a different error message, right? You're stuck in an eternal loop here. This will never stop, right? So, sure, we'll put a retry counter on there. Say after we've retried it 5 times, we'll go ahead and we'll throw an error, right? And then increment that each time that it runs. That is an option. However, if you share this function with somebody, how are they going to know what that retry is, right? That's really kind of something internal to your script. You don't want to expose that out for somebody to be able to change and set, right? So somebody could easily assume that that means the number of times to retry. So, and they set that to 10. Every single time they run this function, it's going to fail. They'll never be able to run it. Right, so a better way to be able to handle things like this is using while loops. Right, so we say while URI, which is same exact what we're doing here. If URI, go ahead and rerun. But this time, it's all built internally into this individual function. Right, so this is just going to keep running. It's going to keep gathering its data. It's going to get what it needs to get. This retry here is internal to it. So you could put a parameter on here to say the number of times to retry, and that would make sense, right? That would give people flexibility to be able to set those types of things, specific to what they're doing, right? And then inside of our while loop, right? So we're coming through, we run our request. So let me go ahead and kick this off real quick. I love when VS Code does that. Anyone else found a good way to fix that without restarting? Okay, so we're going to run through. This is just a simple API. It's actually just running on the background on my machine that is, gathering a bunch of users, right? So again, very, very common request. So this time we're going to build in some try, catch, and finally. All right, so if we get our exception back, so you'll see a lot of try catches of try, catch. If catch, then do this, right? But you can actually parse down through these the exceptions. So whenever you go inside of a catch, $_ becomes the error message that was sent from within your try, right? So when we run this invoke rest method, we failed here, too many requests, right? So we come through, we knew our status code said too many requests. So this is specifically what we're going to do. We're just going to go ahead and sleep our script for 5 seconds. Some APIs will actually come back and tell you how long you have to wait, right? Those are great. They're rare, but they're great, right? Same here again, get unauthorized. Our token expired. Great, put a little code in here to re-auth our token. Again, we keep kind of going through. See, now I'm a teapot, right? I don't have anything built in here for a teapot, right? That's just coming down here and hitting my else. And then we're gonna, increment our retries. And that way, if we do end up in a cycle, never, ever, ever create a while loop without a backup to get out of it, right? Because you could, especially if you're doing cloud processing, right? I've seen jobs run for 3 days straight. You're getting charged by the minute for that job to run because somebody had a while loop in there and that thing's going and going and going and going and going, right? Definitely don't want that. And then on any try catch, there's also finally, right? So don't often see finally used very much. I like to advocate its use. So the finally, for those that aren't familiar with it, is no matter what, if it makes it through the try, if it makes it through the catch, right? I guess I should clarify too. The try, if a terminating error happens within a try, your script goes into the catch, right? That's where your $_ comes. That's where you can get your exception messages from. That's how you can parse through those. If there's no error, it completely skips the catch, right? Finally, regardless of whether or not it makes it through without errors or it does have errors, the finally is always going to run, right? So you have that ability to say, whether I error or not, I'm gonna run. In this case, I'm just doing a pretty simple write host out, getting my users, and I was able to return all of this. So you see here, I ran this, I ran into multiple errors along the way, but there were things I was able to account for. And even ones I wasn't able to account for, right? Because sometimes it happens. Sometimes there's a solar flare, right? Sometimes there's a network blip. Things happen. You're gathering, 500, thousands, tens of thousands of lines of code. You don't want that thing to break because of one little blip in the middle, and then you have to start all over again, right? Those are the kind of what ifs. Those are the type of things that you want to think of as you're building out these processes, right? And then also, some of it comes down to what your commands are. In this case, it did return back 429s and 403s and 418s and all those type of things. So you do need to kind of be familiar with what you're doing with. But these, the try catch and those things will work for any command that's in there. One thing to mention, so error action, right? So every PowerShell commandlet and every function that is written well will have the commandlet binding on it, which allows you to use the built-in PowerShell flags, the verbose, error actions, warning actions, error variables, those type of things, which allows PowerShell to do its thing, right? You use what's built into PowerShell, right? So I'm not going to come down here and write my own custom error handling conditions and things like that, right? What I'm going to do, because you'll often see a lot of people will set error action silently continue, which I actually have in my next script, because for simplicity's sake. But when you silently continue, you don't know what went wrong, right? You know something went wrong, but you don't know what. So, for example, if you're trying to, build a storage account inside of Azure, right? You tell it, new storage account, or get storage account to check to see if it already exists. If it doesn't exist, we want to create it, right? You don't want to error your script on that, so you'll put a error action silently continue. The problem is, if you're not authenticated to Azure, it's going to fail. You're not going to know that's why it failed. You will on the next command when it tries to create it, but that's not really good coding practices. You don't want something further down in your script. You don't want to depend on it erroring out to let you know that something earlier had a problem, right? You want to know when that problem happened, why that problem happened. So a lot of that kind of comes down to, hey, let me run this command, make it fail, right? I can't tell you how many times I'll come in here and just do a simple foo equals $_ run my script, capture whatever that error message was. I can then bring that back into my script and see exactly what that message was. That's how I was able to determine exception, reason, status, code, all of those type of things, is because I ran through that. I captured those error messages as I saw them come through. I had my write output here where I got these, so I could easily come in here and build another exception code for 418 errors. Any questions so far?
I'm curious on the exception handling. Instead of just catching any particular object, right? You're going in with the if and if else statements or else if statements. Is that a reason for that? I mean, you can do multiple catch statements, right?
You could nest them, yeah, and you can also say catch if the exception type is this. Yes. That
So it's just a different approach.
it's a different approach. Yeah, that you'll see that a lot more in like C# itself. That's very common. In PowerShell, it can get kind of tricky because a lot of times that error will just come back as a PowerShell error, a PS object error. So it makes it a little bit more difficult. I've always just kind of found it easier. Some of them don't come back with error codes. Some of them don't, have fully qualified IDs. It's kind of a crapshoot on which ones you're going to get. So, but yes, you can nest different catches and build, like exceptions into them, just like you would with an if else into there. Common one you'll see that is with HTTP. So if you can capture the headers that came back and type things, but again, it becomes kind of a crapshoot on that. Good question. So, our next one, file transfer what ifs. All right? What if a duplicate file name exists? What if it's the same file or just the same name? Right? How do we determine that? What if the destination is unreachable? Right? So, real life scenario I've had, which falls into the next one, is I need to add a new source. Right? So I had a customer who we were collecting billing data from. They were a healthcare provider across the United States. So you can imagine how many insurance companies, Medicare, Medicaid, everything they had to get bills from. Some came from FTP, some came from direct download, some came via email, all those type of things. Right? So we couldn't really build a single script that would go through and say, go get from this FTP, then upload over here, or copy over here, those type of things, because the source has always changed, right? So when you're thinking about that, you want to think about how are you designing your automation, right? So in this case, with a file transfer, put your download and your uploads in completely separate scripts, right? Because what happens if I need to add a new source? Now I got to go in and I got to make all these changes to this source script. Right, but this upload script still stays the same. I'm just telling this upload script to go look in this folder and everything I've downloaded, go in there, right? So if the destination becomes unreachable and I have that all in one script, then what happens, right? I download a file, it goes down to the next part in the script and says upload this file. Well, that upload fails. So now when I run the script from the top again, is it going to know about that other script, right? So those are the type of things that you need to think about, And finally, what if the cloud is full? Well, that's probably unlikely to happen, right? So that's probably where we'll stop. No, I don't remember my own custom functions, do I? Right, so take a look here, right, at a pretty simple file download function. Pay no mind to the man behind the curtain. Okay. So pretty standard function here, right? So what we have here, so I'll come down here. Right, so just a pretty standard invoke REST method. This is going to return me back a list of files I need to download, right? This could be from an FTP, this could be from anywhere, right? It doesn't matter because your upload is going to be completely different, right? But we'll come here, we'll say, if the directory that we need doesn't exist, we'll go ahead and we'll create it. Then we'll join the file names together, and we can even throw a, if file path doesn't already exist, go ahead and add it to it. And we can even put a date stamp on here, be able to do that. Although, anyone tell me why I wouldn't want to do that timestamp?
Run it twice in the same day.
Yep, perfect. So we'll get back to that in a second. All right, but I can go ahead and I can run this. And I'll see my downloads pop in here. So we got these two files. All right. What happens if I run it again and those files still exist on that system? So I have the test path in here, which is going to rename it. So it renamed it. Put this on the end. All right, this is the same file. This is a different file. But I have no way of knowing that, right, before I download that. Now, in my upload folder, I can get a little fancier, right? Since I already have the file, I can do a hash check on it and things like that. So I can say, hey, if this name matches something that already exists, let me do a hash check. Well, here's the problem. I don't have another file that exists with this name. So even though this file is the same as this one, I don't know about that anymore, right? I'm just assuming that this is a new file because I decided to rename it, right? So that's the type of thing that you need to think about. So, a pretty simple way to get around that is we'll go ahead and actually download to a new path. All right, so instead of going straight to a download path, I'm going to create a class with the toFileTime UTC. All right, so toFileTime, that is the number of ticks since January 1st, 1601. So unless somebody else runs the script at the same exact millisecond as you're going to have a unique value there each time. If you really need it to be unique, use a GUID, but the chances of you hitting another millisecond with somebody else are pretty slim, right? So now when I run this, right, it's going to create a new folder, download those two files into it. Now that I have those files, if I run it again, it's going to do the same thing. Now we created another folder. So we've duplicated these, but now we know, now we can run a test and say, hey, for all these ones I have named invoice 123, let's check the hash on them and they're the same. And if they are, well, I only need to keep one, right? So now, what I can do is I can now upload these, right? So I'm gonna upload them to a blob. So this is so I first had ChatGPT help me write this script. You want to guess what it did to check what the blobs were, what the hash was for the blob? It downloaded it and checked the hash. So we have a simple get child here. It says give me all the source files, and then get me my storage. And I'm using my silently continue, which don't do. I just did that so y'all don't have to look at a whole bunch of stuff for demo purposes. But again, all right, and we're gonna check and see if we have a matching blob. If we do, that information already exists in a blob account. All right, so let me go ahead and kick this off. Right, so if you don't have another choice but to download that hash, right, some of the options that you would have is maybe use a SQLite database, and you can record like last 7 days worth, right? Now, how often you expect to get duplicates, right? You can record those in there, or a SharePoint list, which I've used in the past as well, to be able to come through and say, hey, have I already downloaded this file? What was the hash on that, right? Be able to record that instead of having to re-download and bring things back each and every time, right? But obviously getting the local file hash is pretty straightforward, right? We run that. We see our local hash here now. And then we run our one till we go when we get that blob from Azure. And this is going to come back, and it's going to actually have our hash with it. So Azure automatically records that hash for you so that you don't have to go through back and get it. Unfortunately, it doesn't come back clean, as you'll see. It comes back as a bit array. So we can do just a nice quick little 2-string, convert it from the hexadecimal, and we get our blob hash. All right, so PowerShell is not case sensitive, so those will match, right? So now we can run through the rest of our script. Say, duplicate file was found. Let me turn off my break. All right, so now we see here, duplicate found. Not going to go ahead and upload that, right? This one, yeah, a file with the same name exists, but it's not the same file. So what am I going to do? I'm going to go ahead and I'm going to, tack that timestamp, that file time UTC, onto the end of it, so that now I know that I have a unique file that I can upload and those type of things. Obviously it's not perfect because, if you have duplicates of duplicates, but you get the point right here, right? So file upload works great. This function's working perfect. Again, if I need to change this down the line, right? We moved to AWS. This now needs to go into Glacier storage. Don't need to touch my download scripts. Those are fine. All I need to do is create a new upload script and put that in there, right? So breaking apart, modularizing it, right? And creating those, I like to refer to as kind of building blocks, right? Because now I can use this file upload. It doesn't have to be unique to this one collection of invoices. I can use this anywhere I need to, put blobs. This is just another tool that I now have in my tool belt. Same with the download script, right? If I need to download, again, from multiple sources, from HTTP, from FTP, wherever I'm getting it from, I just put all those tools together, combine them together, and then we have our functions, our things that we're able to maintain, right? Same with if we go back and look at our new user here, right? If I need to add a new attribute in here, all I have to do is add it here at the very top of the script. I don't need to go down in here and reset this and add in different attributes here, because what I'm doing is I'm getting that hash table that I created at the beginning and just telling it to loop through that and run that for each time that I go through. To be able to do that same, each time, so that I can easily add, maintain, update this script without having to go through and do a whole bunch of different changes, find, where did I set job title at, those type of things, right? Really kind of keep it clean. You could even, go a little bit further and have it, do some checks here to ensure that the value is not null. You could build in your own, custom checks and stuff like that. So it's good. They're good ways to kind of think about, when you're writing a script, when you're writing an automation, think about what's a way that it could break. But again, back to the file download or the error handling, right? What's a way that it could break? But what's also a way that somebody else could break it, right? So think about that as well. So not just something that could go wrong with the functionality of the script or whatever service you're talking to, but the people that are going to use it next, right? What issues could they run into? What issues could they cause? And if I get a 1 zettabyte file in my upload script, what's that going to do to it? Those type of things that you want to kind of look at and be cognizant of. So that I'll just kind of open it up to questions. Anybody has anything? Or so it's something that has to run, right? So that example is literally just an output, not really anything that needed to go. A really good example of that is if I want to return my error message, right? So I don't necessarily want to terminate my script because something went wrong, but I want to know that something went wrong. I can create a return object that's going to have either my error message or my success message from either one that runs, and that's going to get returned back to my main script every time that it runs. So it's going to always hit that finally. So no matter what happens in there, even if I have an error inside the catch, as long as it's not terminating, my finally is going to hit. It's going to run. Another one is deconstructing things, shutting down connections, things like that, right? You would put those inside of finally. So if I'm doing a SQL call, right? I'm setting my connection to the SQL server, my connection string, initiating that connection, whether that actually completes or not, I still want to close that connection, right? I would put that inside of the finally so that it always runs. No, I mean, it depends on what, what I'm doing. A more common one would be, just kind of like one, like if I had a common scenario is, get service, right? If I want to stop a service, but that service doesn't exist, right? I want to know that it doesn't exist, because if my stop failed because it doesn't exist, well, then I don't care, right? If it failed for something else. So I always have something inside of that catch that is looking for it, right? Or otherwise, I would just terminate my script at that point, right? I don't want to continue on because I had an error. So, but I use the catch when I have an error that I can recover from, right? So if I know something, another one that I've done a lot is with storage SAS tokens, right? If you get a storage SAS token, you set that time to right now, and then you immediately try to use that token to pull something down from a blob storage, it's going to fail. You got about a 3-second window in there where it's not going to fail. So I'll often build in a catch on that to just give myself a little buffer. Instead of building into my script a set always delay on this, right? I'm going to go ahead and let's try it once. If it fails because of that SAS token that says it's not active yet, all right, go ahead and rest for 2 seconds. Now try it again. Now we succeeded. Right? So every time I call that, I don't need to have, so I can call that into a function over and over again. I don't need to have that delay in there every time, just when I error.
When you typically are developing your scripts like that, are you catching errors and then is it like preferable to write them to a log file?
Yeah, it kind of depends on what you're doing, but yeah, there's oftentimes write it to a log. One thing that I will often do too as well is, like I showed you, I just do the foo equals $underscore. Many times I've done added to the end of that, convert to JSON, out file, and then I can have I can go through and I can actually exactly what is inside of that error message and be able to build my logic off of that.
In one of your scripts, you had output type at the top near the parameters. What's the benefit of doing that? Is it the same as returning a statically typed variable?
Which one was that?
It was at the very top of one of your scripts. I'd like to find that one there. Output type.
Oh, yeah. So that's saying that what this function is going to return will be a string object. So it's part of the command. So the PowerShell, as I mentioned earlier, this commandlet binding, when you put this into your function, it's going to tell your function that you can now use the error action, you can use verbose, you can use what if. It's going to pass all of those in there. The output type it's like strong typing, right? It's going to tell the variable that you're returning to that this is a string.
Got it. Is there a benefit to doing it this way versus when you do when you actually return the variable, just statically setting it as string on the return?
Yeah. So here, right? No matter how many times I run it, it's going to do that, and the PowerShell is going to know.
Oh, okay.
All right. So I turned it off. But yeah, if you do your help functions, it will, when they auto build that out, it will know that that's supposed to be a string. So in your documentation, it knows it's a string. If you accidentally set this to an int, it's going to fire back at you and be like, you're not returning a string. So it's a good way to kind of force that in there. The logging, as mentioned, yeah. So a common scenario is, we mentioned with the file download, right? That you're going to have it, those built into separate processes, but there's oftentimes where you'll have one process call another, right? And you need to be able to determine whether or not that returned back. In PowerShell, there's multiple different ways to be able to call a subprocess, right? So you can use the dot notation where you've seen where it's dot / and then I run another PowerShell script, And what that does is that returns it back to your original script, so that if there was an error inside of there, your original script can handle it. If you use the ampersand on there, it's going to spawn it in a new process, and it's not necessarily going to return it. So you need to be able to pull that back. Often what I'll do, I don't ever use the ampersand. I'll use an invoke process in that, and I'll create a whole new PowerShell run space. And you can set output variables that come back in from that. Right, that's actually something that's going to be on my talk on Thursday on Bicep. But there's, as I mentioned, the built-in PowerShell types. Right, there is error variable. Right, so if I set this, I will then get that error back from that message built into a variable that I can then work with and be able to kind of go through and do things along those lines as well. So it's a kind of a mixture of different processes, right? If they're all independent of each other, I'll log them. All right, now I may have a master script that I'll go through and check those logs and see if something went wrong. Otherwise, run an independent process, bring those back. I hate to plug myself, but it's in a chapter in my book where, and all the code for my book, by the way, is free on GitHub, so I'm not trying to self-promote it, but you can invoke those sub-processes, right, to be able to have things that run over and over again, so that you're not beholden to the error messages of other items. If that makes sense. Sorry, I'm kind of rambling, but let's see if I can pull that up. All right, so a good example of that is if I need to monitor something once a minute, right? And if I find that action, then I want to take that action, but I don't want to pause my script that entire time, right? And also, if I have 10 actions, I don't want to, I want them to be able to run in parallel, all right? So what I'm doing here is using the start process to call PowerShell, right? So it's kind of hard to read. Some of the limitations on writing a book, you can't have a line longer than 77 characters, so that's why you see a lot of this. But so I'm calling PowerShell, I'm doing a brand new item, and then what I'm doing is I'm doing a PID count just to see how long those processes are running. Right, so I can set another amount of concurrent jobs. This job maintains running while all those are off doing themselves. So if one of those 10 has something wrong, everything else still stays running and keeps going. And this is all up on my GitHub. Dowst pretty much everywhere. So with that, I think we are at time. Okay, y'all. Yep.